Compressor is not starting. Why won't the compressor start? We're going to do some troubleshooting and figure out maybe if it's a blown fuse, bad capacitor, or a burnt wire, or a bad compressor. We're going to see if we can get it running again. You're watching HVAC Tips for Technicians. I'm Tad. This is Taddy Digest. Let's get started. Got a call from the customer. They said it's not doing anything. We tried the heat mode, we tried the cooling mode. I said that's probably something simple, maybe no power. So just got here, let's dive in. We got an American Standard package heat pump. So it's all electric. I've got both of the covers off of the disconnects. You can see this one's practically brand new and it's non-fused. This one's a little bit older and you can see the fuses. There's two fuses. So keep that in mind. First thing I did when I got here was I took off this panel using a 5/16 and my drill. Then I found the contactor. And when I found the contactor, I pushed in the plunger. I didn't hear a compressor or a fan come on. Be careful when you do this. So I don't think we have power. So what do? Got my meter, set the dial to volts AC, take your meter leads, find the line side of the contactor, place the meter leads on the line side of the contactor, and see what we get for voltage. 0. All right, so we don't have any power. That's why nothing's happening. Now this disconnect feeds the heating element. So our auxiliary heater, emergency heat. And then this disconnect feeds that contactor. So take the disconnect out. Now one thing you can do is you can check the incoming and the outgoing power. If you have power coming in, but no power going out, that could be your fuse. Oh, looks like there's no screw here. So yeah, we could do that. All right, set my meter up. Grab my meter leads. Now, where's the power coming in? Okay, looks like this wire over here. So the wire's on the outside. So power coming in from here to here, 253. All right, now, of course, we're not going to have any power going out because we don't have our disconnect plugged in, our plug for our disconnect in. 0, of course. Now let's check each fuse. So let's put our dial to continuity or ohms, and let's go across each fuse. That one is good. It's reading a resistance reading. It's got continuity. OL, open loop. So reading resistance over here, reading nothing over here. This fuse is faulty. Let's get another fuse. Double checking the max overcurrent protection or the max fuse size that we should be using for this unit. It's 30 amps and that's what this fuse is. See, 30 amp. So let's get a 30 amp fuse. Here's a new 30 amp fuse. Put it in place. And if you have two, you may want to go ahead and ask the homeowner, hey, do you want me to go ahead and just change both fuses? I know there's only one that's bad, but we can go ahead and upgrade both just in case. So now, resistance reading. And over here, resistance reading. So both of the fuses are now good. Let's place it back into the disconnect. Beautiful. Be careful when you do this. All right. Oh, I heard the fan, but I don't hear the compressor. That is not good. Now I'm going to push the plunger in for the contactor, and at the same time, I'm measuring the inrush current with my meter. I've got it on AAC, and I've hit the inrush button right there on the side. So we're on the common winding of the compressor, and we're going to be measuring that as I push this plunger in. So here we go, 3, 2, 1. 75 amps, but you can't hear it running. Wow, that's interesting. Oh, there it goes. There it goes, it just kicked on. Interesting, all right. So we got the compressor running. Let's do that one more time. Let's hit select. We're not going to check inrush. We are going to check running amps now. So it's pulling about, it's gaining. I'm so glad it's running. That's awesome. We got to check capacitors though now. Compressor is still running. It's pulling about 7 amps, staying pretty steady. I went ahead and gave it a call by connecting the red and the yellow wire, the R and the Y, and I didn't forget to connect the green because I want the fan to run as well. Otherwise, that's going to affect the amp draw if the indoor fan's not pulling air across the evaporator. So let's check and see what the RLA should be. Run load amps, 12.8, and it's below that. And then LRA, 65, and it did 75 on startup. And that's not unusual. So now it's working. It's in heat mode because the reversing valve is not energized. Now I'm going to go ahead and unplug the disconnect and check the capacitors. It took it a while to start up, so I'm just curious. It's got a start capacitor. I wonder if it's drained. Make sure. Unplug this one too. We're going to set our dial on our meter to MFD. We're going to check the capacitance of each one of these capacitors. We've got the run capacitor, which is for the outdoor fan motor and compressor. We've got the start capacitor, which is for just the compressor, and the potential relay. So this is used to drop out the start winding after that compressor starts. So we've got our meter on MFD. First thing we're going to do is we're going to take and check the start capacitor. So we're going to take our wires off of the terminals of the start capacitor. And what's this rated for? Can't really see the numbers. We're just going to check it and then we'll take it out. So here's how we check it. What do we got? Measuring 0. So that's not good. Okay, now instead of taking the run capacitor out as well, I'm just going to take the wires off of the terminal that is labeled H, which is for Herm or hermetic. I don't have to take the wires off of the C, even though I'm going to be using the meter leads across the C. So we're on MFD. Meter leads going from C to H terminals. What do we got? 21. That's pretty good. What's it rated for? Can't really see that. 25.5. Okay, so this capacitor and this capacitor need to be replaced. So we're going to go ahead, take out the start. That's one way to do it. And what's it rated for? 135 to 162. No bueno. All right. All right. What do I got here? I don't have a 25, I've got a 30/5. So that'll work. I don't have a potential relay and a start capacitor. So I'm going to replace both of those with this ICM 856 solid state relay and hard start capacitor. Let's do it. So here's what we took out. We took out the run capacitor. We took out the start capacitor. We took out the potential relay, which had a 1/4" screw holding it in there. And then we took out all of these wires. And these are the wires that connected not only the start capacitor to the potential relay, but also the potential relay to the run capacitor, to the Herm terminal specifically. So now that we've got all this removed, what we're going to do first, before we install the new capacitors, is we're going to put our dial of our meter on MFD, and I'm going to go between C and H. We're just going to see, is this really reading 30? 29.61, that's close enough. Now let's measure the start, or a hard start kit. Meter leads connected to the spades that are connected to the wires to this little hard start kit here. It's reading 148.6. What should it read? It says in between 130 and 156. Now, is this compatible? 130, 156, this is 130, 162, 135, 162. So yes, this is gonna work just fine. Before I mount the capacitors in place, I want you to see the wiring. So you can see that the little solid state relay and hard start capacitor has two wires. One wire and spade connects to the HERM terminal, and the other wire and spade connects to the C terminal. Then you'll notice that there's one less wire than we had before, and that was we had an extra orange wire that went from the HERM terminal, this run capacitor, dual run capacitor, to the potential relay. So we removed that. And this is how you wire the hard start kit. Super simple. I'm gonna go ahead and mount these capacitors in place. Both capacitors mounted, looking good. I had to move this bracket down to be able to have enough wire to reach the run capacitor or dual run capacitor. I've got one side of the coil disconnected, right? That way the contactor does not pull in when I put the fuses back in the disconnect. Now I've got my meter set on AAC, and we are going to check the inrush current. So hit select, inrush twice. Let's plug this wire back in. All right, here we go. 24. Wow. Started immediately. That's amazing. All right, we definitely got to recheck that. But it's looking great right now. Let's check just the running current. 7, so it's about the same. All right, I'm going to take the call away, disconnect, plug it back in. There it is. Took away the call. I'm going to just push in the contactor, and we're going to check that inrush current one more time. Here we go. 3, 2, 1. 69.9. Looking good. Here's a few more tips for why the compressor may not be starting. One could be a burnt wire. That burnt wire could be in between the contactor and that compressor. It could actually be at the compressor where the terminals are. You may need to take the cover off where the compressor terminals are, make sure you have the power disconnected, and there could be a burnt wire inside. So check your burnt wires in the condenser section, check for burnt wires at the actual compressor terminals. Then another thing that could be wrong could be that the compressor has overheated and it's gotten too hot. And what happens when it overheats? Then you have a protection device that is called an overload, a thermal overload, and that will take and open, and then you'll have an open winding, and that will keep the compressor from running so it can cool down. So what can we do? Well, first, to know if your compressor is hot, make sure you turn off the power. You can take your hand and feel the top of the compressor, and if it's overheated, it's going to be really hot. You can also take an infrared gun, a thermometer gun, and you can take the temperature, the surface temperature of the compressor, and see if it's 150, 200 degrees. That will be an indication, oh wow, it's hot. You can actually take and measure the windings with your meter. You disconnect the common, the start, and the run, and then you go between common and start and common and run. We would do that at the actual contactor. So we take those 3 wires loose, make sure the power is disconnected. How to cool it down? Easy. Get a water hose. Run the water hose over the compressor. I've got a video of this. If you want to learn more about that, I'm going to post a link down below. Glad we could get that compressor started again. Let's look at the size. It's a 30, so it's a 2.5 ton. 2001, so it's about 25 years old. That is excellent. I love those rotolocks and those old orange compressors. This is definitely my favorite unit. I love it when a unit lasts 25 years. And now we're going to make it last 30, I hope. Let me know in the comments what you think. Let's do a little bit of schematic reading. Find our compressor, There it is. Compressor, outdoor fan motor, indoor fan motor. Compressor's got 3 wires. CSR, that is black, orange, red. Common, start, run. Go over here, it says CR, it says CF. So I think that's condenser fan. That's where the fan goes on the F terminal. CR, compressor, run, capacitor. This is where the HERM terminal is. So this is the dual run capacitor. Go over here, it says CS, compressor start, and then CSR, compressor start relay. So we've got our coil for the potential relay. We got our contacts, looks like they're normally closed. You can see all this. Learn how to read schematics. It's going to help you. Let's take our meter, put it on ohms or continuity, and then we're going to take our meter leads and go between, I think it was 2 and 1 said normally closed, so we should read continuity, and we do. Look at that. So if this was normally open, we would read nothing. And then it said between 2 and 5 is the coil. So it should read about 10 or 15. Look at that, 14. Look at that. So this relay is still good. Hope you enjoyed today's video. Hope you learned something. If you did learn something, let me know what it was down in the comments. You got a question? Remember, questions can lead to new content. So put your questions down below. Don't forget to go check out the video I put down below about learning more about open windings, how to check. And then also there's a video on how to replace a compressor. So if you don't have experience, go watch that video, learn how to replace a compressor so that you're ready in the field. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live experience as a technician in the field to help you be a better technician. If you like this video, hit the like button, subscribe, smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, this was Taddy Digest, and I'll keep you cool if you let me.